This is the data collection demonstration video for the Induction lab of Physics and Engineering 217. In this lab, what we'll be doing is taking a magnet that we'll have attached to the CNC so that you can control the position, and we'll be moving that magnet in front of a coil of wire. That moving magnetic field will induce some sort of voltage in that coil of wire, which we can then measure with the DAC. So we'll be moving this magnet at various speeds in front of this coil of wire, and we'll be recording the resulting EMF with the DAC. And from that data that we'll collect by passing that magnet at different speeds, you'll be able to answer some different questions that we'll be asking you and your team to calculate and determine an answer to in the lab manual there. So here we'll be covering the equipment and setup that we have for this lab. So the first item we have is this induction coil mounted up where the camera would normally be mounted. This particular one here is a 500 turn coil, so there's a single wrap of copper wire passing 500 times around the circumference of that coil. And what we will be doing with this is connecting this coil up to our DAC. So here we have a BNC to banana cable, and we will simply plug our two ends of the cable into the coil, and the other end we will plug into channel 0 of the DAC here. The next bit of equipment we have here is our magnet. This is a strong neodymium magnet, similar to the one that we would have used in the previous labs with Lorentz force and the magnetic field probe. And what we'll be doing with this magnet is passing it in front of the coil in order to induce some sort of EMF that we can then measure with the DAC. In order to control that magnet passage in a highly controlled way, we'll be attaching that to the CNC here. So we also have this piece of steel, just a little U-channel segment, that we'll be attaching to the CNC here. And then once that's fixed, we can attach our magnet to the piece of steel like so. So that's all that we have set up for this lab, and we can now begin looking at the actual data collection procedure here. So before we go into the full data collection run for this lab, we'll take a look at the software and script we have available for data collection here in order to become familiar with its functionality first. So we'll list out the contents of this example scanning directory here. And inside of this we have this run induction sweeper piece of code. And this is the script we can run for our data collection here. So we'll copy that out to our home directory. And now we can open up that code and take a look at what it's actually doing and some of the parameters that we may be able to set there. So when first taking a look at this, you should notice this is a very short piece of code compared to some of the other scripts we've run in lab here. So we'll step through what this script is doing in its entirety here. So this very first line, we're just doing some imports. We're importing this induction sweeper class that we'll be using. Here we are instantiating the induction sweeper class, so we're creating our own instance of that, and we're passing along some variable here, sweep distance. Sweep distance is how far the magnet will travel for a single pass across the coil in millimeters. So we're currently going to travel 400 millimeters across the coil there. And then our last line on the code here is we're just performing one of those sweeps, where we're also passing in some particular parameters here. So the speed parameter we're passing in, this is how fast the CNC will be moving the magnet in millimeters per second. The x-adjust value has to do with how far back the magnet is from our center position on the coil. We will not be using that in our data collection here today, so we can skip that one for now. And then finally we have that channel parameter, and that is simply going to be specifying the DAC channel that we'll be reading from for a single collection. So that's all that we have in this script here. So before we make any changes and again go about our data collection, we're going to see what this script just does if we run it here. So we're going to exit out and we'll launch this script here. And so the first thing that it's going to do here, as with any of the CNC using scripts, it's going to home that CNC to define its 000 position. And then here we'll take some background sample rate calculations. This is just what the program will use internally to figure out how many data points it needs to collect from the DAC. We are now going to be prompted to specify the center of the coil here. And so to do that, we'll be measuring how far the center of the coil is from our initial magnet position. So here we're just being prompted to enter some initial guesses. We'll be given an opportunity later to refine that further. But to find these initial guesses, we can simply use a meter stick here. So from our starting magnet position, we can say that the induction coil is probably about 250 millimeters in the x direction. And then measuring in our next direction, we can say that's probably about 550 for y, and we can use those as our starting values here. So for our initial x, again, we'll put in 250 millimeters. For our initial y, we'll say 550 millimeters. And we didn't take a z measurement here, so we'll just call that an initial guess of 0. So putting those initial values in, the CNC will move the magnet to that specified position, and then we'll be allowed to make some tweaks and adjustments from there. Okay, so our magnet's moved into position, and we're now prompted here to specify whether that is actually centered or not. And we are not quite centered here, so we'll say no, and we'll make some fine adjustments. So probably can't tell on camera, but it looks like the magnet is a little bit back from our coil here still. So we'll take a couple steps a little closer. We want to get that magnet as close as we can to the coil in order to get a good signal without running into the coil when we're taking one of our passes here. So that looks a little bit better. So we can set 0 and then move on to our next direction. So for the y direction, the magnet's actually a little far to the right here, which is defined as the positive y direction. So here we'll step back a little bit in y. And that actually looks good there with that -20, so we can put a 0 in there now. And for our z, we'll obviously want to raise that up so we're a bit more centered on the magnet here. And it looks like that's about where we want to be, so we can hit 0 now. And now the script will print out what those final values were. So that's the initial estimates we had made with those little small steps we took in the x, y, and z directions on top of that. So these values here we can write down and store if we need to run the script again. That way we wouldn't necessarily need to go through this adjustment process. However, we're prompted now to go ahead and hit enter to take a sweep. So we'll hit enter here. The magnet will move into the beginning position for this sweep pass that's ready to take. And we'll hit enter. It'll move the magnet in front of the coil with some velocity that we specified with that speed parameter. While the magnet's moving, the DAC will be taking all these voltage readings from the coil, and that's what we're plotting up on screen there. So on the y-axis we have the voltage being read by the DAC on channel 0, and on the x-axis we just have time. So this is the kind of shape we're seeing on that plot there, so we can hit enter to finish up the script. The CNC returns to the home position, and the script's complete. So if we take a list here now, we can see we have one new file, and this is the output that we'll get from taking a single sweep here. This is a CSV containing the same information that we saw up on the plot there. So this will be a CSV containing as the X data, timestamp information, and on the Y data that will be the voltage readings taken for a given pass. And these different chunks in the file name here specify those parameters we used in the code here. So this V100 MMPS, this is reflecting that speed value we had set in the code of 100 millimeters per second. Here's that X offset value that, again, we didn't specify anything here in this lab, so it's left to 0. And here's the DAC channel that we read from. So this will be the output from one particular pass. We can now take a look at what the full data collection might look like for this lab here. So now that we've already looked at the script that we have available for this lab and we're familiar with the functionality, we can take a look at our full data collection run for this lab. In the deliverables, we are asking teams to assess how the velocity we move the magnet in front of the coil changes the voltage that we measure from the DAC while taking that pass. So if we look at our code here, one way of addressing that problem might be to alter the speed parameter. So we could take a data collection run with this set to 100 like we had just shown. We could come back in, edit the code, take this to 200, save it, run the script again, come back in here, change it to 300, run the script again, etc., until we have enough data to begin analyzing that question. However, if what we're doing is coming back into this same piece of code, running the same line of code over and over again, just changing one value, a different solution should spring to mind, and that solution would be a loop. So here we can introduce a for loop. So here we'll say for velocity in range, and then we can specify what range of values we would like this velocity parameter to take. So here we can specify our starting value, 50 millimeters per second, our ending value of 750 millimeters per second, and then this last parameter being our step size. So as we go through this loop, for our first pass-through velocity, we'll have a value of 50, then a value of 100, then 150, etc. On our next line here, we will indent that in to indicate that it is in fact part of that loop. And then within this line, the only change we will need to make here is, instead of just saying 300 or specifying that value explicitly, we'll just tell it for the speed of that pass, use whatever this velocity variable is set to. So that's all the changes we'll need to make in this code in order to just step through a range of different velocities automatically without having to edit it every single time. So we'll exit out here, we'll save the script, and now we can launch that chunk of code. And much like last time, it'll begin by homing the CNC and then taking some background readings in order to determine its own sample rate. We'll then be prompted to enter in those initial guesses. Since we have run this script before and already did the adjustment, we can simply enter in those values we found previously, and they should be just fine here. So now the magnet will move into that position we specified here. And then we'll be prompted to enter in whether that is centered or not. In this case, since we've already done that adjustment since our previous run and this looks quite centered, we can just say yes here. So now we're prompted to hit enter to move into the initial position, and then we can hit enter to take our scripts. Or sweeps rather. So this very first one will be at that 50 millimeters per second value, so it's going to be moving very slowly here. It'll take those readings, we'll display that plot up on screen, and then we're prompted to hit enter again here. So now we'll be stepping up that velocity, so this will be our 100 millimeters per second pass. We can perform that again, do our 150 millimeters per second, etc., stepping up the velocity parameter every time we loop through that chunk of code. And you can see the different plots being generated by each sweep up on screen there. So we'll just continue to step through some of these quickly here. And that was our last pass, so our magnet and CNC are going to return to the home position. Now if we list out the contents of our home directory now, you'll see we have many different CSVs here. So what we have is a single CSV generated for each pass that we took going in front of the induction coil here with the magnet. And again, as we saw before in our first step through, these different file names here are going to reflect the parameters used when taking that data run. So here this would be our sweep taken at 100 millimeters per second. Here would be the sweep taken at 150 millimeters per second. This would be our 200 pass, etc., all the way up to the 700 value. So this is the data we'll have available for the analysis for this lab. We'll have all these different CSVs posted that you can use to perform the analysis and report for this lab.